Hey, good morning, everyone. We're going to let a few folks trickle in here. We appreciate you taking the time today to join us. We're excited that everybody's here. We're going to do a brief dive here into dry pipe fire sprinkler systems. We're going to go through how you maintain them. We'll provide some recommendations, and then we'll go through some of the common issues that we've seen over our time here at Ryan Fire. As we get rolling, if anybody has questions, feel free to type them in the chat box. Also, there is a link in the chat box. If you want to go ahead and click that link, excuse me, and put your first and last name in there, it'll give you the opportunity to be entered into the drawing for a $50 gift card at the end of the presentation. So myself and Edwin will be presenting today. I'm Adam. I work out of our Louisville office. I've been with Ryan going on 9 years. I've spent 4 years in our Noblesville headquarters and then an additional 4.5 down here in Louisville, managing the Kentucky and Southern Indiana markets. Edwin is our sales manager for Northern and Central Indiana. He's been with Ryan Fire going on 10. So what are we going to be doing today? Here's a quick snapshot. We'll give you a introduction to who we are and what we do. We'll do the dry sprinkler system overview. We'll give you some requirements that you folks need to worry about on your end. We'll get into the maintenance of dry systems. We'll talk about the common issues and then the recommendations that we have on our end. So who are we? Our mothership, we're located in Noblesville, Indiana. We have branch offices in Fort Wayne, Valparaiso, South Bend, Louisville, Milwaukee, and Bloomington. So kind of scattered throughout the Midwest there. Happy to be celebrating our 31st year in business. We focused on inspection and testing of fire sprinkler, fire alarm, special hazards, and fire extinguishers. Outside of testing and inspecting, we also do design, fabricate, and install all of those systems as well. Family owned and operated by 2 brothers, awesome culture, and we're sitting at about 300 employees to date. So these are the 2 code books that we're going to be referencing throughout the presentation today. We'll touch a little bit on NFPA 13, which is the standard for installation of water-based fire systems. Don't be confused. I know we're talking about dry systems, but a dry system is a water-based fire protection system. And then most of our content is going to come from NFPA 25, which is the ITM, or inspection, testing, and maintenance of water-based fire protection systems. And for those of you who don't know, NFPA stands for National Fire Protection Association. And those are kind of our Bibles, or our everyday. We're in these books every day, all day long. Over to you, Edwin.
Thanks, Adam. So the first question that I'm sure everyone has, if you don't know, is what is a dry sprinkler system? First and foremost, a dry sprinkler system is a fire protection system or water-based system that is filled with either compressed air or compressed nitrogen in lieu of water throughout the entire system. The air or nitrogen is pressurized to keep what we call the clapper, which is the internal component of the dry valve, closed in the dry valve that keeps water from entering the system, so that you can use it in certain spaces where ambient temperature is below 40 degrees. How does a dry system extinguish a fire? So when a fire is present and sets a sprinkler head off, just like it does in a regular wet type sprinkler system, the air or nitrogen that is compressed inside the system will be exhausted through that particular sprinkler head or heads until the pressure exceeds the required air or nitrogen pressure to release the clapper, open the clapper, thus flooding the system with water and ultimately extinguishing the fire. So a lot of people ask, a common question we get here, when you look at the dry valve picture on the right, you'll see 2 gauges. A lot of folks ask, why are there 2 gauges? I look at my gauge on a dry system, why are the pressures different? So the way a dry system works, there's usually a 1-to-3 ratio on air pressure to water pressure. The reason is the surface area on the top side of the dry valve versus the bottom side is 1/3 of the size on the bottom. So you need there's more surface area on the top. You need less air pressure to hold down more water pressure. For example, If you have 60 pounds of water pressure coming from the city on the bottom side, you only technically need 20 pounds of air pressure in order to keep it closed. And that just helps with your air compressor not having to run or have to work as hard, and helps with maintenance. So that's a little brief dive into what a dry system is and how a dry system works. Next is building owner requirements. So this particular portion comes from NFPA 25, and this is what's required of you as the maintenance staff or the building owner to maintain your dry system. There's a lot of pieces to this puzzle, but specifically for dry systems, it's very important that the room enclosure or the room in which your dry valve is installed maintains a 40-degree Fahrenheit ambient temperature or above. The reason for this is there is water on the bottom side of that dry valve, and you do not want that to freeze. Otherwise, you will have issues and your dry valve will not operate as it's intended to do. The other piece is maintain low point drains. So throughout a dry system, you're going to have low point drains, and inspectors tests. They're going to look like drum drips, we call them, or low point drains. You look at the picture we have on the slide here. The building is responsible for maintaining those. Typically, during the summer months or warm weather months, you really only need to do this once every month, every other month to drain those, and our guys can teach you how to do that. During cold weather months, like right now, it's best that we probably do this every week, every other week, just to make sure, even if you only get, you know, an ounce or 2 ounces of water or a quart of water out of it, it's imperative that you make sure this gets drained to eliminate any problems of freezing. Corrections and repairs. So if there's issues with your dry system that need fixed, that's found during an annual inspection, it's the building owner's responsibility to get those done, typically by a qualified contractor. And lastly is just to maintain records of your inspection, testing, and maintenance. Next is the inspection, testing, and maintenance of your dry system. So this comes from NFPA 25 as well, which is similar to the last program we did a month ago. I won't get too much into the details of Chapter 5 and 13, but that's where all this information comes from. And there is a difference between inspection. That's a visual look at and see, make sure everything looks and appears to be in good working order. Testing is the physical operation of the equipment and devices, and then maintenance is actually physically working on or fixing something or doing some sort of preventative maintenance to make sure that the system will operate. A big thing I want to hit here with dry fire sprinkler maintenance is there's some additional inspections required beyond that of the annual and quarterly that you see over on the right in those boxes, and that is a 3-year air leakage and a 3-year full trip. For those that don't know, a 3-year leakage is used to identify any leaks or major leaks in a system before a major event or before an issue happens. And how this works is we pump the system up to a certain PSI reading, and then we remove air pressure, and it has to maintain a certain amount of air pressure throughout a 2-hour period without dropping. I believe it's plus or minus 3 pounds. If it loses plus or minus 3 pounds within that 2-hour period, a further investigation needs to be completed in order to determine why it dropped, that particular amount of PSI, and then get those problems. The other piece of this is a 3-year full trip. So on a typical annual inspection, we'll trip a dry system. What that means is we will exhaust the air out of a remote inspector's test. Once that system trips, we'll immediately close the control valve to not allow water to go and flood your entire dry system, and prevent any issues from happening. Every 3 years, we're required to flood the system completely. This is done for a couple of reasons. Number one, make sure there's no blockages or issues within the piping itself and allowing water to get to the most remote point of the sprinkler system. The other is to identify if there are any leaks present in your sprinkler system. We recommend typically to do the 3-year air leakage to identify those leaks prior to the 3-year full trip, so that we don't create any issues, or if there is a leak, we don't ruin a ceiling tile or get water on some drywall ceiling or something of that nature. Adam?
Thank you, sir. So as you can see, as we're moving along here, some of you folks might have dry systems. You may have just dry systems. You may have dry systems and wet systems. But as you can see, as we're rolling along, dry systems have a lot of additional requirements from a code standpoint than a wet system would. So we thought this was really neat to share with everyone. The head testing is a lot different than what you would expect from a wet system. So they're a lot different. To the right here, we pictured a dry pendant, and I do want to share a video on how that operates here in a second. But if your dry system does have dry sprinkler heads, we're required to take a representative sample of those heads and send them to our laboratory and get them tested to ensure that they're working adequately. Oftentimes, folks may have 8 dry pendants on one dry system, and it really wouldn't make sense for us to test 4 sprinkler heads, which is what is required for us to do. So we would probably recommend, let's just replace them all, and then you have your 10-year grace period. So something to think about there, that we look at dry pendants differently, and it's a situational thing. Harsh environments, we provided some examples down here below on what harsh environments are. So in these harsh environments, we have to test or replace these heads every 5 years. I'm going to stick with the word test though. So what is an example of a harsh environment? You know, mills, foundries, parking garages, areas that are exposed or open air, and cold storage. So you know, think about like a tire factory. They make rubber, they make tires. There's a lot of stuff floating around in the air. We would consider that a harsh environment. If you have an overhang outside your building that has 20 uprights on it and you're storing pallets underneath it, that would be a harsh environment. I want to share a video on how these dry pendants work. Kind of interesting. No sound here. So a lot of different types and brands of dry heads. I just chose this one because I thought they had a great video online of what the barrel actually does in the event of a fire. So we'll see here in a second, the flames will come up and activate this sprinkler head. So these dry pendants also can be ordered down to the 1/4 inch. So we see the flames here. Activating the bulb on the sprinkler head. It pops. Now we're going to see that washer in the cap fall down, break away. This is going to fall down. Now we're going to go to the top of the barrel. And this is going to rotate, allowing water or air, and then the sprinkler head discharges. So I thought that was pretty cool for folks to see. Not everybody gets to see or understand what happens there. So back to you, Edwin.
Thanks, Adam. Next thing we want to talk about here is just some common issues we find in dry systems. We have a lot of customers call and say, hey, this happened, this is happening, or asking us why is that happening or whatever. So we just compiled some of those common issues and put them on here. Now there's obviously more than this, and if you have issues, feel free to reach out to Adam, myself, or one of our account managers to kind of walk you through the process and what may or may not be causing that. But a couple of high points here. The lifespan of a dry system is much shorter than that of a wet sprinkler system. So the average lifespan of a dry system is usually actually only 10 to 15 years when utilizing compressed air. If you utilize compressed nitrogen, you can typically get 25 plus years out of it, which Adam will get into the nitrogen here in just a few minutes. The other thing is low point drains. So what I mean by that is they're not being maintained. So previously I spoke about, you know, building owner requirements. Along with our help, we help you maintain those low points. Those not being maintained typically have an issue because what happens is they get filled up with water at the low points, and it can be not necessarily from a system tripping, but it can be from just condensation, especially in the Midwest here, when you got a day where it's 75 degrees in the afternoon, and the next day it's 35 degrees, right? It breeds a lot of condensation. Then what will happen is those areas, when it gets cold, can freeze and break and cause issues. Another thing we see is pinhole leaks and corrosion. Adam, when he gets into the nitrogen, he'll explain the corrosion piece, what it is. A lot of myth. We got a really good understanding and grasp on this and how that works. We see a lot of pinhole leaks from corrosion that cause the compressor to run, so it causes compressor issues. It causes systems to accidentally or inadvertently trip, and of course we all know that happens at the worst possible times, like New Year's Eve or Christmas Day or something crazy, when everybody wants to be enjoying time with their family and friends. Another issue we see is ambient temperatures. Now this is not something that you as a building owner can necessarily control if it's outside or protecting an area that is exposed to the elements. But we do see, like I mentioned before, ambient temperatures can affect the life of a sprinkler system from the hot and cold and the condensation that happens that breeds corrosion. 5-year internal failures is something that we see quite a lot with dry systems. You see the picture on the right. We've shown this picture before. This is a picture of actual dry system that we did a 5-year internal inspection, and this is what was in the piping. It was clogged full of mud. There's reasons for that. I won't get into the details now, but things like this can happen. So it's important to make sure you're following the recommended inspections per NFPA, which is the 3 years and the 5 years, etc. Lastly, here is air compressor maintenance. Some air compressors are oilless. Some you need to change the oil. Some are tankless. Some have tanks. If they have tanks, a lot of times there's a requirement to get water and condensation built up in those tanks. You need to drain that. Changing belts every so often, depending on the manufacturer's recommendation, etc. So those are the biggest issues we see. Now, one of the most common questions we get, and I would say we probably get this at least once a week, especially in the wintertime: why is my air compressor running all the time? And that is a very good question, very valid question. It can be a couple of things, and it typically, however, is you have a pinhole leak somewhere in your dry system that you can't see, or that's hidden behind a wall or above a ceiling, that you can't hear the water hissing, or the air hissing out of it, but there is a leak someplace. Your air compressor should only be running 2, 3, 4 times a day for maybe 30 seconds. If it runs more frequently than that, if it's running every hour, you probably have a leak someplace. We should probably, or somebody should probably come and investigate that, or have your maintenance staff investigate where a leak may be, so we can get that fixed before it gets any worse. So if you have questions on why air compressor is running frequently or all the time, feel free to reach out. We can help you diagnose that.
Thanks, Edwin. So as you can see, we keep bringing up the same issues. There can be a lot of headaches associated with dry systems if you're not doing the right things. So what do we recommend out of the things that we've seen so far? Well, we've noticed one thing, that these inspection requirements that we find in NFPA 25 aren't typically enforced. They're just letting folks like you inspect these systems annually, which is completely fine, but we really need to get eyes on these systems more frequently, on a quarterly basis, a weekly basis, a monthly, and still doing our annual as well. So the more we're looking at it, the more we're messing with it, the easier it is for us to find an issue before it pops up. Another thing is some folks aren't draining their low points regularly, or looking at their gauges, or they're not checking the oil in their air compressor. Some of this stuff can be done in-house because people are staffed for it, but others aren't. So if you have a dry system and you have 2 low points, you probably could figure out a way to get those drained weekly throughout the year. But if you have 120 low points, you may not be staffed for that. That could take some time. So some of our existing clients do have us do this sort of work for them because they're just not staffed for it. So, and like Edwin mentioned earlier, we're happy to help with these checklists. We can create them for you. We can train your maintenance staff or whoever to do these. So don't be afraid to reach out and have us and use us as a resource. It doesn't cost you any money to do that. So the last item that we would highly recommend is nitrogen. We could devote at least an hour talking about nitrogen, and we would recommend you install it on a system that's 20 years old, 10 years old, 5 years old, brand new. And I'll get into a little bit. I'll get into why we think that and why we know that's true. So this technology is definitely extending the system lifespans much further than it is without. So essentially what it's doing is it's stopping corrosion in its tracks. We have case studies that we can share with you folks where customers were experiencing multiple leaks over the course of a year, say, I don't know, 5, 10, 15. They installed a nitrogen generator and replaced a few lengths of pipe that were already bad, and no leaks anymore. So for years. So how is that happening? Well, what we're doing is we're taking oxygen out of the system. Okay, once we take oxygen out of the system and we replace it with nitrogen, the leaks and the corrosion stop. So the corrosion survives through oxygen. It's its food. This technology is definitely catching on really quick. Major box stores like Walmart and even the government is using it in some of their facilities. It's something that I definitely recommend any facility with a sprinkler system, wet or dry, consider. The cost impact isn't that significant. It really depends on the size and the volume of the system. And like I said earlier, we could spend 30 minutes to an hour talking about this. So if you're sitting here thinking, I'm on the fence, I want to learn more about nitrogen, please reach out to us. It doesn't cost you anything for us to come out and educate you, do a survey of your facility, and provide an estimate. It's something that we highly recommend. So if you take away anything today, definitely think about nitrogen in your future. So where do we find dry systems? Where do we typically install them? Where do we see them? I mean, we definitely see them in attic spaces a lot, apartment communities, nursing homes, assisted living, very old buildings that were built maybe in the early 1900s that are made of wood, that are made of combustible materials. We see them in parking garages a ton. Edwin actually has a really good story. I'm kind of putting him on the spot right now about a parking garage in Indianapolis, I believe, that maybe he'd share with us after this. But parking garages traditionally are open air, so it's a perfect application for a dry system. Canopies and awnings that are also open air. And then we see them in large warehouses that store food, that are distribution centers for food, medicine, things like that. So these are the most common places that we see them. Now, that doesn't mean that there's a person sitting in this training thinking, well, I have a dry system and I keep my warehouse at 65 degrees all year long. Why do I need a dry system? Well, maybe you don't. So reach out to us and use us as a resource, as I said, and we can come out and evaluate that, and maybe you don't need a dry system. So we're really thankful that everyone joined us today. We're trying to keep these short and sweet and not take a bunch of your time. We're covering a lot of information really quickly, so if there's questions outside of this that you want to have, feel free to reach out. Give Edwin and I a second here to look at the chat box. We're going to announce the winner as well. So we'd love for you to stay on. If there's a bunch of questions in here, I need to jump over here and take a look, but give us a second here. We're going to announce the winner of the drawing. Let me see, I just got it in. It is John Radonati, Radnoti. Congrats, John. Thanks for joining us today. All right, Edwin.
Yeah, we're gonna get to some of these questions here. There's a few over on us. Yeah, if you have questions, feel free to post them. Um, One thing I will say, we're gonna try to answer all the questions here while we go. I know we have a 30-minute limit. We may go beyond the 30 minutes, but full disclosure, if you need to jump off, by all means, feel free. Don't feel like you have to hang around, but we want to try to get some of these questions answered for those that are on here so they know best we can. So, I don't know if you want, I can take the first one here.
Sure.
If you want. So Steve asks, is this documented on the system with a tag, or is it just in the paperwork? I believe he's referring to the 3-year air leakage and the 3-year full trip. If it is on the paperwork, how would the inspector know the system is due for the 3-year test to make sure it is done? Steve, that's a great question. We kind of fight this battle every day out there in the field when it comes to inspecting facilities that we have not inspected in the past, and even ones we have. So the way we do it here is we have a program called Service Trade that we utilize, and we keep track of that documentation in Service Trade. And when 3-year full trips are due or 3-year air leakage tests are due, we will provide a proposal with your deficiencies, if there are deficiencies, to get that done, because it is above and beyond the typical annual maintenance. We also will typically write that on the tag on the riser when the last 3-year full trip or 3-year leakage is done. If for some reason a technician that does slip his mind, he does forget, we do typically have that information at our fingertips in the paperwork on our servers. So we can certainly help you with that. But how we do it and how everybody else does it, it does vary. And I don't think there's not a perfect way to do it. There should be a tag typically, so anybody comes in there to look, they know when it was done last. Just like a 5-year inspection tag, we hang tag from the areas and from the piping where we took apart and the check valves, so that you know it was completed. So I hope that helps answer your question. If you need further information, feel free to read after this, and we can help you.
Thanks, Edwin. I'm going to take this question from Anonymous. Besides a nitrogen system, is there another way to prevent condensation and moisture in our dry system? Yes and no. So there is a system that comes with a compressor, and it's called a dry pack. And what that does is that will remove moisture and condensation from your system, but it does nothing to help with corrosion. And maybe corrosion isn't your problem. And there also might be some other underlying things here that we don't know. So maybe there's some fluctuating temperatures that are causing condensation, and that's why you're getting a lot of water out of your drum drips on a weekly basis. I don't know where this is at, but I think we would definitely like to come out there and take a look at what you have, because you do have two options, but maybe nitrogen or a dry pack system isn't the answer. Maybe it's something else. But to answer your question, yes, there is. It's called a dry pack system.
Thanks, Adam. We have a question here from Mike. And Mike's question is, what's the cost delta for an airburst nitrogen system? And that is a tough question to answer without knowing all the details of your system. There's a lot of variables at play when it comes to a nitrogen system. The company we use has, 10 to a dozen different nitrogen generator sizes. And the way we do nitrogen is we take the total volume of air or gas or water, whatever we could get, whichever you want to refer to in the system. So if your system holds, for example, 200 gallons, there's some calculations we do to determine the size of nitrogen generator that it will take in order to feed that system effectively. And there are small wall mount systems that have an internal compressor that just mount on your wall that are small, like one Adam had a picture of in a slide deck. There are also, which we've installed before, are skid mount that are the size of a phone booth or bigger. So it varies, and obviously the cost varies for each of those, and the installation varies for each of those because of the size and complexity of the system. So the short answer is it depends. We would need to do an analysis of your facility to determine exactly what the cost difference would be between the two, if that makes sense.
Great, nice. Yeah, I think, you know, the wall mount generators are really easy to size, so don't feel discouraged. It's really simple for us to come out and do a quick assessment and look at your piping and give you a price on one of the wall mounts. Not tough at all. All right. Do you provide a copy of the inspection report to the AHJ or just your customer? Well, the answer to that question is going to vary, but the answer to that question is yes, we provide documentation to, at least in Louisville, and I know in Indianapolis as well. Edwin knows a little bit more about the Chicago market, so he can go through that. But yeah, in Louisville, for example, we're required to send our inspection documentation to the state fire marshal. You also get it, and the fire marshal. In Indianapolis, Edwin, correct me if I'm wrong, I believe the fire department uses Mobilize, and we submit all of our inspection documentation to them. Is that correct?
That's correct. Yeah, Indianapolis and some surrounding counties. It's growing here in Indianapolis, and the major metropolitan Indianapolis area is using Mobilize, where we are required to submit documentation to Mobilize along with to the building owner. We typically let the owner know if there's major issues that the building owner or manager typically knows about the issue before it gets to Mobilize, so they're not blindsided. I will note that Fort Wayne, Indiana has recently adopted a program called iRoll, which is very similar to that. It's an online portal that we have to submit documentation to. So if you're in a Fort Wayne market, just know there's another, it's got another name for it. In the Chicagoland market, they have what's called the Compliance Engine or Bricer. It's essentially the same thing. It's a portal that we must submit documentation to let them know that we have completed the inspection and what we found during that inspection.
Thanks, Edwin. Looks like we have a couple more.
Yeah, I see the next one here. I'll go ahead and answer it real quick, Adam. It's from Mike. What do you call a low point? A low point is usually called one of two things, either a low point drain or a drum drip. Looks like Adam's going to that picture. We call how it came up with the name drum drip. I'm not exactly sure. I'm sure I could fumble through and make something up, but it would be simply that, made up. The picture there you see next to the responsibility is what we call a drum drip. There's a valve on the top and the bottom. Typically the top valve is open, the bottom valve is closed. And then when we drain it, we just reverse it. The key is making sure that one valve is closed at all times so that you don't exhaust the air and accidentally trip the system as if a sprinkler head had went off. So in this particular instance, you would close the top valve and then open the bottom valve, drain the water, and then you would close the bottom valve, open the top valve to allow any excess water that did not make it in there because it was at capacity to enter that drum, we would call it, and then repeat those steps over and over until you get no more water.
Yeah, so I mean, essentially, as we were talking earlier, you know, the installation of a dry system is much more important than it is with a wet, as it relates to how it's pitched. So we always want water to go back to the low point, the drum drip, or the main drain. So that's kind of how we distinguish it, and that's why it's so important for these to be maintained on a weekly basis if it was up to me. So Katie asks, if the compressor fails, will it fill the system with water? Well, eventually it will. So if your air compressor and your dry system has all the appropriate switches that are working, your low air switch, and you're monitored, your monitoring company will call you and let you know that your system is losing air, and the compressor is either doing one of two things. You know, it's not able to keep up, or it's down and it's not working. It's broke. So, Katie, it's tough to tell you when it's going to fill your system with water, because we don't know how well your system holds air. So if your compressor is running every 15 minutes and your compressor breaks, you probably don't have much time before it fills with water. So anything to add, Edwin?
No, yeah, the short answer there is it depends on the integrity of the system itself. So like Adam said, if your compressor is running every 15 minutes, every 30 minutes, it's going to happen quicker than if it was running 3 times a day. And if your system's brand new and your compressor fails because power went out or whatever, you may have 3 days before it trips and exhausts. But like Adam said, there are some fail-safes in place with what we call low air pressure switch that will alarm you if your air gets below a certain PSI before the system actually trips. So there are some indicators that will happen so that you're notified ahead of time. And if you get those, if anybody on this call, if you get a low air alarm, the first thing you should do is call our 1-800 number, and you'll get to, or call Adam or I directly, and you'll get to one of us. And we can walk you through the steps to prevent that from happening, prevent your system from tripping until we can get guys on site, get that compressor fixed.
Yeah. Perfect. Any other questions?
I saw Mike put on here, he asked how to get contacted. I put my email address in the box in the Q&A. So my email address is right there. If somebody wants to reach out directly, either myself personally will help you, or I'll get you at least in the right direction. If you're in Adam's territory, I can get you to Adam. So feel free to send me an email if you have any questions directly.
Well, if that's it, we appreciate the time today, and congrats, John, on winning the gift card. We'll get that out to you as soon as we can, and look forward for the next virtual training. Should be around the corner here soon. Thanks, everyone.
Thanks.
See ya.